Before LeNet 5, recognition systems had serious limitations. If a digit shifted slightly, the system failed. If there was noise, the system failed. If writing style changed, accuracy collapsed. Models like Perceptron could only separate linearly separable data. MLPs ignored spatial structures completely. The world needed something different, not handcrafted intelligence, but learned intelligence. Yann LeCun and his team asked a radical question: what if network could learn features directly from raw pixels? No manual extraction, no engineered pipelines, just an input image, some learned representations, and an output prediction of your existing class. Mathematically, for every real number, there exists a class 0 to 9. The training was optimized using cross entropy laws, but the real innovation was not just the loss function, it was how the network showed the world. Slides across the entire image. That's weight sharing, which means fewer parameters and translation invariance. Better generalization. This single idea solved variability in handwriting, and suddenly the network did not just memorize digits, it understood patterns. Now let's see the architecture pipeline of the model LeNet 5 layer by layer. The first is a input layer. It takes in a 32 cross 32 grayscale image. It is just a raw pixel image, nothing special. The purpose of C3 layer is to learn deeper features. It has 16 filters. Corners and curves are learned during this filter. The network begins to understand the shapes. Followed by this, we have the S4 layer, that is compression layer. This reduces the image size to 5 cross 5 into 16 to contain more meaning in less space. Now the network sees the entire digit shapes. This is no longer edge detection. This is digit identity forming. Next to this, we have the scene 7 F6 layer, the dense classification layer, and then the output layer. This has 84 neurons, then finally 10 outputs going into a softmax, a probability distribution. The digit is recognized, all with just 61,750 parameters, and in 1998 without GPU. Do you think this was a revolution? Yes, it was a revolution. From hierarchical feature learning, end-to-end supervised learning, efficient backpropagation in convolution layers, 10H nonlinearities, and parameter sharing. We already discussed the feature maps, the output and input size of each layer. You can see the overview in the existing image. The activation functions and number of parameters in each layer is also listed for your reference. The layer-wise analysis with complete detail as described few seconds ago is presented for a better understanding. You can see the number of filters, the kernel size, the purpose of each layer, and number of input neurons and output neurons per layer. A beautiful visual representation of how the data flows through each layer, from convolution, subsampling, then subsampling, then a fully connected softmax layer is shown in the following figure. Years later, many models were proposed based on the baseline of this LeNet 5. LXNet went deeper using GPUs. ResNet solved vanishing gradient problems with skip connections. Inception used multi-scale kernels. MobileNet reduced computation with depth-wise convolution. Transformers introduced self-intention. But every one of them stands on LeNet's shoulders. The DNA of modern vision problems, local receptive fields, feature hierarchies, shared weights, all were born here. Even today, LeNet 5 is ideal for banking OCR, industry QA, IoT devices, embedded systems, and edge AI because of its lightweight, fast, reliable features. And we all know in the domain of machine learning, sometimes simplicity wins over complexity. LeNet 5 did something profound. It showed the world that deep neural networks could work, not theoretically, not hypothetically, but practically. It transformed computer vision from handcrafted engineering into learned representation, from rules to data, from manual pipelines to end-to-end learning. And this shift created the modern AI. Today we train billion parameter transformers, but in 1998 a small network with 61,750 parameters quietly started a revolution. It was the beginning of deep learning for vision. If you enjoyed this story, subscribe for more deep dives into the models that built AI. Next episode, we'll go with ResNet, the network that made depth possible. Paper AI signing off.